Hey, George, you're a scientist.
I'm a chemist, yes.
Yeah, right. You're a scientist. So, why, like, why is the ocean salty? Because, like, it's like rain's not salty, and like lakes and rivers aren't salty, but why? Why just the ocean? Why not all water?
It's just got a bad attitude. That's why it's salty. Darn it, lions. Darn it, lions. I'm a chemist, not a geologist, but with my very limited area of expertise and very limited knowledge and background, I'll attempt to opine to this. So, to your point, right, is that this one actually gave me pause because I was like, yeah, the ocean's salty. And I kind of, double checked a couple things. I'm like, yeah, no, this makes sense. And then I was like, wait, but why aren't lakes and rivers salty? And then I went down the rabbit hole, right? So let me take a step back and ask you about, because I don't want to talk about that right now. What I want to talk about is booze. So,
why is this cocktail salty?
As you look at it, it's a margarita. It just has salt around the rim. And it's like, and this feels
everything checks out.
Are you familiar with how a distillation process works?
Yeah, I think so. It's like you have like a liquid with stuff in it, and I think you like boil the liquid so that the heavier stuff precipitates out, and then like the water or whatever the liquid is like separates, and then you do something to not let them recombine, and then you have the stuff and whatever the stuff was like suspended in.
Yeah, pretty much, right? So you heat, you don't necessarily have to boil it, right? And it's
no,
a way
boil it.
Always boil it. And so it is a way to like separate out contaminants typically, right? So one of the interesting things you can do with some chemicals is that, like, for example, let's say you've got a mixture of methylene chloride and water, right? Which don't mix super well, or any two for example, ethanol and water, right? Is if you set the temperature correctly, you can attempt to predominantly boil off the ethanol and leave behind the water, right? Which is why, like, or you can boil it a little bit hotter and capture some of the water, right? But you would leave behind anything that's even heavier and boils less than water, which is why it's like, it's triple distilled vodka. And it's like, oh, it's pure vodka. It's got less garbage in it, right? In theory. So what you do is you heat the thing. And so the lower boiling point stuff kind of gets heated up, and then it's put through like a condenser, right? Which is normally a glass tube that has water flowing around it, cold water, which makes it colder. And so then as it hits that, it condenses down and then drips down.
So you kind of gestured with your hand, but for the folks listening, is a condenser always one of those little spirally? Like,
it is generally one of the spiralies.
Okay, because that has got to be like, it's in the running for like science movie thing. Like, how do I know this person is a mad scientist? Because they have a spiral glass tube with liquid in it.
They absolutely do. And you know what drives me banana pants crazy about that is every time they show it, they show the liquid going from like a flask and it goes up into a thing and then it goes through the spirally thing. That's not what you do. You put water through the spirally thing. The distillate goes through the center bit. So they're using it wrong 99% of the time, like, so like, look, it's spiraling around. It's like, is that where it because it goes to waste after that. Generally, it's like the point of that is that it's the cool thing that's cooling it all off, and then like the stuff that goes to the center part is what you're trying to collect. So yeah, no, I'm very familiar with that. It cheeks me every time I see it. That and of course the fact that how can you tell if somebody's doing chemistry? It's like, well, look at all of the different color solutions.
So many colors.
So many colors. I remember turning to my wife at one point and being like, it's not like that. And she's like, well, why? And I'm like, because if everything had its own color, I wouldn't have a job. Because you just look at it and be like, ooh, it's blue, it's cobalt, as opposed to like, oh no, I need to put it into an instrument that will tell me whether or not it's cobalt. But yeah, you got it, right? Yes. So you boil the thing, or you heat the thing, you put it through famous chemistry sets, and then you get the other thing, right? So interestingly, what works? So let's put a pin in all that. I'm done talking about booze now. Thank you so much for going on that journey with me. But let's now talk about the water cycle, right? So do you remember from elementary school what the water cycle is?
Yeah, so you have some water like on the ground,
Yep.
like an ocean or a lake, and
Mhm.
the sun bombards it with free energy that apparently we are too good for, and that
Way too good for.
that
We want to
evaporates.
use the energy of the stuff that used that energy millions of years ago.
Yes, please. So then that evaporates some of the water, which then travels high enough that it condenses in the colder upper atmosphere into clouds, and then eventually the clouds. I think I kind of remember what makes rain eventually become rain, but eventually the clouds become rain, and then it rains back down, and now we've returned to the beginning.
You got it. Yep. So evaporation, condensation, and then precipitation, right? Yeah. And what you said, right?
Yeah. Yeah, no, it's funny because this is how I know I'm old and distant from school, is because saying it in those terms did not even occur to me. Like, I know those words, like those
Yep.
are words that I know, but a kid who just learned those words would use those words, and a scientist who needs to speak about science would use those words. But a layperson is just like, "Meh, here's the broad concept, I think."
But the awesome thing is now that since we've done this episode, Emily's going to come home from school at one point, and say like, I learned about the water cycle. And you're just going to crack your knuckles and be like, all right, well, let me tell you some stuff.
Here we go.
So interestingly, so the water, boils, not boils, but is evaporates up from the ocean, right? And then when it rains, it tends to hit solid mass, right? When it hits the solid mass, rain tends to be slightly acidic. And so as it, hits solid stuff and then slowly combines into rivers and then slowly goes out to sea, it dissolves some of the geology and in the process tends to release salts, sodium, magnesium, potassium, all those sulfates, all that stuff, right? And that leaches out. So the first thing of, well, why are lakes fresh, or why are rivers fresh water? They're not. They just have very low volumes of sodium in them to the point where we would consider them to be freshwater. But they absolutely have minerals in them, which is why like people are like, oh, I gotta get this fresh mineral water straight from the lake. And it's like, stop doing that because you don't know what's upstream. Like every time I hear somebody say, yeah, I get this water straight from the lake. I mean, that's fine. It's fine, whatever. But like, I just feel the hearts of 1,000 water treatment plant workers just crack. They're like, we're working so hard to make sure that this water is clean to drink. And you're like, I'm going to get the stuff that somebody pooped in a mile upstream.
Well, that's also like a very cold climate mentality. It's like you and I spent a lot of our young lives in the deep south. And no one would say like, I'm going to drink from this fresh lake water. Like those lakes killed people. The things in those lakes killed people. Like you would never consider that a fresh source of water if the air is hot, right? If the air is hot, stagnant water is not fresh water.
No, I mean, I feel like that when you grow up in the deep south with that, you learn the word fetid a lot earlier than people up north, right?
Big time.
like that just is a more commonly thrown around piece of vocabulary. So basically, then what happens is that the water in the ocean is basically consistently undergoing a distillation process where the ocean is what's left behind, right? So what happens is that the water boils or, evaporates up. It then condenses down and it brings a whole bunch of junk from the land into it. All of that junk stays because, all the salts and stuff stay in the ocean. And then it, repeats the cycle. So slowly over time, all of that stuff washes into the ocean and the ocean retains it, right? So then the next immediate question that I was like, okay. And then, so I wrote all that down. I'm like, I feel prepared to do the episode. I'm like, Lines is going to ask, what about lakes?
He is going to ask about lakes because ¿por qué no los lakes? Like,
and the reason why lakes are still also considered to be freshwater is it's the amount of the water that is coming from precipitation versus runoff and how much is being lost proportionally to evaporation, right? So that's the thing is that the less it's losing to evaporation, right, proportional to the amount it's gaining from direct precipitation is different than the amount of the ocean, right?
Right.
So like the total amount of sum total of water in lakes compared to the sum total of water even by surface area on the Earth, the ocean like far outstrips lakes. You know, so that means that more of the water in precipitation is coming from the oceans, and the lakes are benefiting effectively somewhat equally from it, right? You know, and there's not as many rivers and tributaries that feed lakes as there are that feed the oceans, you know?
Which is like one of those scale things that humans are not awesome at, because like I'm following you, but there is that like layman part of me that's just like, but a lake is just sitting there. Eventually, shouldn't it be saltwater? And it's like, no, for like reasons you can understand the math of. No. And it's just like, but it's so much smaller than an ocean. Shouldn't it eventually be salty? No.
Yeah. Is it basically, I think that the way because I was also like, okay, because I was like, if I'm going to explain this, I need to really understand it. And the way, so I kind of wrote it down 3 or 4 different times to make sure I understood it. But basically, is the way I eventually conceptualized it is what percentage of the water is coming from precipitation and what percentage of the water is coming from runoff, right? And in lakes, you've just, in the ocean, right, is that you've way up to runoff and, you know, downgraded precipitation, and you've flipped that with lakes. So proportionally more water from lakes comes from rainwater, and thus it is able to be fresh, you know? So yeah.
So the ocean is salty because the earth is.
Yes, because the earth and all of its geology, right? Like it slowly, all of the stuff leaches from, and again, like this is why, you know, ocean and water pollution is like a real thing, is because everything that we do on land eventually gets covered in water, and all the water eventually goes to the ocean. And the fact that it would be horrible, but you know, the more acidic the rain, the worse that problem is going to get, you know?
Right, because then it pulls more stuff out of the geology that it's running through.
Yep, and that's why, you know, like for a while, because do you remember when we were younger, like hearing a lot about like acid rain?
Acid rain, yes. And when I think of acid rain, I think of specifically the opening to the Bill Murray Scrooged movie, because he makes this like insane promo for the live action Scrooge that they're going to do. So you see it, it's because it's commercial for the thing they're getting ready to do live on Christmas Eve, and it just lists all of these horrible things, and the premise of the ad is that all of those things are not as bad as if you miss the live action Scrooge. Like that would be the actual worst thing. Acid rain is one of the things they list, but also there was a panic in like the late 70s and early 80s that people were leaning out of their car windows and like shooting random people on the highway. It wasn't really a thing. I mean, I'm sure it's happened like once, but like it was not there wasn't like an epidemic of highway shootings. But that's also one of the things he lists. He's like, acid rain, and this woman is like, she like runs toward the camera and she's screaming and like clutching her head, and then it's highway killers, and this guy in like an 80s like suit with the sleeves pushed up just leans out of the window with a shotgun and just blows this person away.
But yeah. So I can't opine to the highway killers, but I can talk a little bit about acid rain, which is interesting because like that's the thing, is that all science is generally more banal than, you know, it is like fantasized, right? Because we as storytellers want to tell like big, cool, interesting stories, and it's like, so what's the deal with acid rain? It's like its pH is 6 instead of 6.8. You know, like so it's just more acidic than it normally is. But over time, it does cause substantial problems because, and actually, do you know what the cause was for the acid rain and why we don't see it as much anymore?
Ooh, I want to say it was related to some. Oh, was acid rain the same thing that caused the hole in the ozone layer?
No. Those were chlorofluorocarbons and aerosols. The thing that caused the acid rain was coal.
Oh, so, it was just regular ass pollutants.
Just good old fashioned coal,
yeah,
you know, because
mundane coal fire plants. Cool.
Yep. Yeah. So like when you burn coal, it releases sulfate amongst other things, and sulfate then goes up into the air and forms sulfuric acid, which, you know, is famously an acid. So, you know, and then I believe in when the EPA was founded, that was one of the things that they went after, were those kind of coal plants, and saying like, hey, you can't keep pumping sulfates into the air, and then we saw that kind of, I believe we saw that curve off. But yes, that's the problem. Is it's not like you're going to walk outside and the rain's going to melt your face. It's more like, hey, one, all of the nice, cool statues that we have are going to look gross in the not too distant future, but also two, that it's just going to cause more things from the geology to leach into, not only leach into the ocean, but also leach into groundwater and stuff like that. So, but yeah, that's why it's salty. It's basically is when you sit there and you drink your triple distilled vodka, just think this is why the ocean is salty.
That cocktail reminds me of another thing I wanted to ask you about.